record the session. Okay. So okay, thank you. Okay, so we will start. Okay, anyway, we have done some example related with Coulomb's law. Okay, and also we have there are some three parts. There are other also there are other uh, three scenarios are there. Okay, we need to find the volume charge. We need to find the electric field generated from a volume charge distributions and surface charge distributions and linear charge distribution, line charge distributions. Okay, so so to find the volume charge and surface charge distribution, you need to know the volume is called what is that called? Volume integral and surface integral. Okay, so I think I show you how to find those volume integral and surface integral. Okay, when we are using rectangular coordinates, spherical coordinates, and cylindrical coordinates. Okay, so those are different from each. Okay, rectangular coordinate no issue. Okay, but in cylindrical and spherical coordinates you need to see. Okay, how the surface integral and volume integral has done. Okay, so I hope as I can remember I show you. Okay, so maybe maybe in last time maybe you have noted it. Okay, anyway I will upload the last time session. Okay, then you can update it. Okay, so what you should know is if you know these if you can remember these three identities, what are they? Okay, yeah, three identities. Okay, so I will write it here. Okay, so one from XYZ coordinate, that means rectangular coordinate. Okay, so if you consider any distance shift, okay, distance shift, vector shift. Okay, so in XY coordinate we can write it as please can you transfer the host for me? Okay, thank you. Okay, I will record again. Record it is done, no? Recording is there. Recording doesn't stop. Okay, I will share the screen. Okay. So basically you should remember, you should keep remember. You should keep remember these identities. Okay. So one is in Cartesian coordinate or rectangular coordinate. Rectangular coordinate. Okay. So any little shift of a vector can be written as, okay, um, dx. This is in head x direction. This is the unit vector. Okay, in our we are normally using this one ax, no, ax as unit vector as I can remember. Okay, plus dy ay plus dz az. Okay, dz az. Okay, so these are derived from curvilinear concept. Okay, you no need to have the concept, but better to keep the idea about these three. Okay, another one is this is rectangular coordinate. If you connect the, if you consider the spherical coordinate, any little shift can be written as dr. This is in r direction, and um, r d theta. This is in theta direction, plus r sine theta. This is in phi direction. Okay, so this is spherical coordinate, and using cylindrical coordinate. Okay, so very little shift can be written as rho d5 in phi direction. Okay, in phi direction, a5 plus d rho in rho direction. This arrow means, the unit vector. Okay, this is the unit vector in this direction, arrow. Okay, so here it is mentioned as rho hat, but we are using this one, a number, to identify the unit vector. To, okay, plus dz in z direction. Okay, so if you can remember these three identities, you can get any integration. Okay, for example, if you want to do a, if you want to do a surface integral or volume integral using rectangular coordinate. Okay, if you want to do the surface integral in dx and dy plane. Okay, so you should have the function. Okay, okay, for example, if you want to find the surface integral, surface volume charge. Okay, okay, so if the volume charge distribution is surface charge distribution is given, any function using a function. Okay, so this function will be a vector actually. Okay, so there will be a vector, this will be a vector. Okay, so that can be uh, integrate. Okay, in x, y, or z with respect to x, y, or z. Okay, that is according to the application. For example, if there is a surface, okay, in xy plane, in x and y plane. Okay, so if you want to find the volume charge, the the surface volume, surface charge of this surface. Okay, so you need to integrate this in y and x direction. No, so you have to evaluate y and x direction, dx and dy, like this. Okay, so if this surface in Z direction, ZX plane, you have to integrate in Z and with respect to Z and with respect to it, dx, dz, so on. Okay. So you can do any surface integration. Okay. And if you consider, let's consider spherical charge distribution. Okay. So you need to find the surface integration of this spherical. Okay. This sphere. Okay. So you can use this spherical coordinate. You can use this spherical coordinate. Okay. So if you consider the sphere, okay, the surface is related with theta and phi. Okay. Theta and phi. Theta is the coordinate. This one. This is the radius, and theta is the angle between z-axis and the radius. Okay. And this is y-axis and this is x-axis. Okay. Then phi is the angle between x-axis and this xy plane. Okay. Theta is in xy plane to this point. Okay. So that is theta, r, and phi. Okay. So definitely, if you want to find the surface integration, okay, you need to integrate with respect to what? R, there are r, theta, phi. So if you need to find the surface integration with respect to what, you should do the integration? With respect to r, with respect to theta, or with respect to phi? Can you give me answer? So I am asking that, okay, there is a sphere, okay. Let's say that this sphere has some charge, okay. This sphere has some charge, okay. So if you need to find the total charge, total surface charge, okay, you need to integrate. You need to find the surface. You need to find the surface integration. Okay, surface integral. Okay, you need to evaluate the surface integral. Okay, so when you are evaluating the surface integral with uh, in which direction you should do that evaluation? කොයි පැත්තටද evaluate කරන්නේ? මේක ස්පියර් එකක් ඔය කට්ටියට surface එක හොයන්න ඕන. surface එක තියෙන්නේ මේ උඩ නේ. එතකොට ඔය කට්ටිය integrate කරන්න ඕන මොකේට respect විදිහටද? R වලින්ද, theta වලින්ද, phi වලින්ද? surface එකේ හොයන්න මොකෙන්ද integrate කරන්න ඕන? මේ R කියන්නේ මෙයාගේ මේ මැද. ඒ කියන්නේ මේ මෙන්න මේ ටිකේ දුර. හරි. එතකොට phi කියන්නේ මේ පැත්තට තියෙන දුර. theta කියන්නේ මේ පැත්තට තියෙන දුර. හරි. Theta is in this direction. Okay, theta is in ZY plane. Theta is in ZY plane. Phi is in XY plane. Okay. R is within the circle, within the sphere. Okay. So in which direction you should do the integration? To find the surface integral, to find the area, to find the surface. That is with respect to theta and phi, no? With respect to theta and phi. With respect to theta and phi. Okay. So if you need to find the surface integration of a sphere, you need to evaluate it with respect to theta. Okay, d theta. So d theta is coming with r d theta. R d theta. Okay. and this r sine theta, sorry, then you need to evaluate it with d5. So this d5 is coming with r sine theta, r sine theta. Okay. So you need to evaluate this r, r is square, sine theta, d theta, d5. Okay. So this is, so the function should be there. The distribution, the charge distribution should be there. Charge distribution function should be there. Then you can integrate this. Okay. So if you want to find the area of a sphere, how you evaluate it? If you want to find the so if I ask you to find the area of a sphere, what you need to do? This is x, sorry, this is z, y, x. Okay, this is z, y, x. Okay. And if you consider any point here, from here, this is r. Okay. So this direction is AR. Okay. And for this point, okay, this angle is theta, sorry, 5. Okay. So that 5 is in this direction. Okay. So it is in this direction. That is A5. That direction is A5. This is a vector. Okay. And theta is this. Theta is in ZY plane. Phi is in ZY plane. Okay. So this is theta. Okay. So it is in this direction. Okay. It is in this direction. So that is A theta. Okay. So if you need to find the surface of this sphere, what you have to do? If you need to find the area of a sphere, what you have to do? What should you have to do? You have to evaluate the integration, no? You have to evaluate the integration. Okay. So you have to evaluate the surface integration because you are going to find the surface. Okay. So you need to do the surface with respect to theta and phi. Okay. So r is square sine theta, d theta, d phi. You need to evaluate this surface. Okay. You need to evaluate this surface. If it is a total surface, this phi is in this direction. So what is the limit for 5? What is the limit for 5? What is the limit for 5? For surface, for the sphere surface. 5 is starting from here, 0. And you have to consider all this area, no? All this point. Okay. So 5 is from 0 to 25. Okay. So 5 is from 0 to 25. Tell me what is the theta? What is the limit for theta? What is the limit for theta? What is the limit for theta? Tell me. Please tell me what is the limit for theta? What is the limit for theta? Is it from 0 to 25? Yes, very good. Okay. Actually, it is not 0 to 25. Okay. It is from, because here you are first evaluating with respect to theta. Okay. So if you are first evaluating this surface up to here, then if you take this from 0 to 25, then whole sphere will cover. Okay. So this theta from should be from this theta should be from 0 to 5, not 2, 5, 0 to 5. Okay. So if you need to evaluate the whole surface, whole uh, sphere, you need to evaluate up to only 0, 5, not up to 0 to 5. Okay. Then R square will become R square divided, sorry, R square, that is, sorry, this is not R square, no? Yeah, R square is there because that is a constant. Okay. R square is a constant. There is no, we doesn't have to integrate with respect to R. Okay. Then if you integrate with V5, it is 5. Okay. 5, the limit is 0 to 2, 5. So it will be 2, 5 to 0 into sine theta d theta. It will be minus cos theta, minus cos theta, minus cos theta. Okay. Minus cos 5, minus cos 5. Cos 5 is 0, no? 1. Cos 5 is minus 1. So it will be minus 1 minus cos 0. Cos 0 is again 1. Okay. So you will have R square 2, 5 minus 1 minus 1 minus 2, again minus 1, it will be 2. So you will have 4, 5 R square. Okay. So what you understand is you need to do the integration with respect to d theta and d phi. Okay. So if you want to evaluate the surface integration of a cylinder like this, okay, okay, with respect to what you should integrate, you should integrate it with respect to, not with respect to rho, okay, but with respect to uh, phi and z, dz, okay. So phi is coming with this one. Phi is coming with rho, okay. So you have to insert the rho here, okay. So your integration will be like this, okay. And this function is there, that is also a vector function, okay. Vector function is there, okay. Sorry, if you are using a vector function here, you have to consider the vector also here, okay. So 5 is a5 and z is az. Those vectors also you need to consider, but here we doesn't consider a vector, we just consider only the surface, okay. So that is why I write like this, okay. So if you are considering the vectors, okay, if this distribution is a vector, you have to also consider the vectors, okay. Okay, so that idea you should know, okay. And when if it is uh, volume charges, if it is volume for a specific spherical, you need to integrate with respect to R also, okay. Surface into R, okay. So that is from 0 to R, 0 to 2, 5, 0 to 5, okay. So R is square, because R is there, R is square sine theta dr d theta d phi, okay. So this is how you find the volume integration, okay. So just evaluate this, you will get the volume of a sphere, okay. You will get the volume of a sphere, okay. Now if you want to find, if you want to evaluate the volume of a is cylinder, you need to evaluate with respect to rho, with respect to 5, and with respect to z. This may be not 0 to z, minus z1 to minus z2 or something. Okay, so function is there. You will have rho, d rho, d5, dz. Okay, so this is the volume integral for uh, uh, cylinder. Okay, I think we have already talked this. Okay, so just move quickly. Okay. Yeah. So that is correct. Okay. Okay, we will move quickly. Okay. Okay. Now, so what I want to tell you is that to evaluate this, to find this surface and volume charges, you need to do that surface and volume integration. Okay. Uh, so I think these examples you can do, no? What do you have to know? Itu balik mau tadi. Harung ya buat. Oh. Okay. Uh, I think these are not much difficult, no? Maybe you can do this by yourself. So here you need to find the uh, volume charge. Okay, volume charge. Okay, the charge density is given. Okay, charge density is given. So you need to find the volume charge in a cylinder. Okay, so you need to find the volume of a cylinder. So you have to evaluate this rho d5 dz. Okay, and this is the volume charge. Okay, so once you evaluate this three integration, you can find it. Okay. Okay, I think this one also you can do by yourself. Okay. So here you are asked to find the total charge within each of the indicated volume. Okay. So this is the first volume. Okay. So volume is defined here. Okay. X, Y, Z from 0, 1 to 0, 2. Okay. X, Y, Z from 0, 1 to 0, 2. Actually, uh, this here, this magnitude is mentioned there. Okay. So if you put magnitude, what it means? If you put magnitude, what it means? For example, if we said that magnitude x is greater than -1, what it means? Okay. So if x is greater than 1, that means if this is x-axis, x is greater than 0.1. Okay. So x is greater than 0.1. This. What happened if we magnitude? If we put the magnitude? Magnitude x is greater than 1. Okay. So this part is there. Okay. And if you consider the minus part, 0, 1, 0, 2, likewise, if you consider the magnitude of this -1, -2, that is again -1, sorry, minus 0, 1, 0.1, 0.2. Okay. So this area also included. Okay. So both area will be included. Okay. Both side will be included. Okay. If it is less than, that means this area. This area. Okay. So here also the magnitude is there. Okay. Here also the magnitude is there. මේ මෙච්චර අමාරු නෑ ඒකයි මම ටක් ගාලා කරන්නේ. කමක් නෑ නේද? Okay. අර මෙන්න මේ equation ටික තමයි විතරයි මතක තියාගන්න ඕන. You should only keep remember these equations. Okay. අපි මේ equation වල derivation වැඩක් නෑ. හරි. derivation අහන්නෙත් නෑ. හරි. මෙන්න මේ තුන මතක තියාගන්න ඉන්නවා නම් ඕන එකක් කරන්න පුළුවන්. හරි. ඔය surface integration වල ඕන එකක් එහෙට මෙහෙට දදා කරන්න තියෙන්නේ. හරි. 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 Okay. So okay. So here, it is mentioned that, okay, Uh, this point 2 also there, no? If the point 2 is there, what happen? It's just like this, okay? If if point 2 is there, that means it is like this, okay? This x1 is greater than 1, and less than 2. Greater than 1 means this area, okay? Less than 1 means this area, okay? Less than 2 means this area, okay? So these are the area. These are the area. Did you get it? What I'm telling, okay? So the limits are given. Magnitude x, okay? So if I write, I will write only the x-axis, okay? If I write the x-axis, okay? Let's say that this is 1, 2, and this is -1, -2, okay? So now x is greater than 1, less than 2. Definitely this area is there, okay? Now there is a magnitude, okay? Magnitude means -1, -2 is also applicable, okay? So this one also there. So this is the area, okay? So this is the area it mentioned, okay? So within each of the indicated volume, okay? Okay. Calculate the total charge within of the indicated volume, okay? So if you consider x, y, z, if you consider x, y, z, z, y, x, no? Okay. So corresponding to plus value, let's consider only plus value. So one area is from, this is x, okay? One area is from uh, one is from point 1 to point 2, point 1 to point 2, point 1 to point 2. And z-axis is again point 1 to point 2, point 1 to point 2. Y-axis is also point 1 to point 2. Okay. So you will have a cube maybe in this location. Okay. මෙන්න මේ වගේ තැනක cube එකක් එනවා මේවා. මේ වගේ cube එකක් එනවා. So what you have to do? And if you consider the minus side, okay, minus side, if you consider the minus side, this minus side, this minus side, then this minus side. So you will have a cube in here like this. Also another cube. So there are two cubes actually. Okay. To find the total charges, you have to find the charges in this cube and this cube. Then you have to multiply it by 2. Okay. And this cube and this cube is identical. Okay. So if you find one cube, once you multiply it by 2, you can get the correct answer. Okay. Okay. I hope you get it. Okay. So we will try to do it. Okay. So now this is our volume charge. Okay. So the function is here. Okay. Now in this case, function is given. Okay. So just try to do the integration. Okay. I will not do the integration. It will take the time. Okay. So here the function is given. So you need to do integrate the function actually. This is the distribution. Okay. This is the distribution. Okay. So you need to distribute 1 x square, y square, z square with respect to dx, dy, dz. Okay. You need to integrate it with respect to dx, dy, dz. And x is from 0.02, y is from 0.02, z is from 0.1 to 0. Okay. So to find the total charge, you have to integrate this. You have to evaluate this integration. Okay. So you can find that integration. Then if you multiply it by 2, that means you have find only this Q in volume charge. Okay. But you need to find here also. This one and this one will be same. Okay. Same. So you have to multiply it by 2. Okay. So what you have to do is you need to evaluate this integration. Okay. I hope you can evaluate this integration. Okay. Should I evaluate this integration? Okay, let's quickly do. Okay. So if it is 1 over x square means you can get x. So I will consider the x. Okay. So x minus 2 integration from 0, 1 to 0, 2. Okay. Another part is there. Okay. Other part is the other integration is there. So what is the answer for this one? X minus 1 divided by minus 1. Okay. From 0 to 0.2. So you will have minus 0.1 minus 1 minus 0.1 minus 1. So you can get this value. That is x. That is some value. We don't know. Maybe x or something. Okay. So you can keep that value x. Then you can multiply it with respect to y. The same answer you will get. Multiply by y. And for z also the same answer you will get a z. Okay. So this is the value. So if you find this value, what is this value? Can you tell me? Zero 0.2 minus 0.1. If you get this minus, then you will have අපිට ගත්ත එක නේද? මේක පහ දෙන්න. 10 බෙදීම 2 5යි. අපිට මේකත් උඩ එකක් 10න් වැඩි කරා කි මේකත් උඩ එකෙන් 10න් වැඩි කරා 10 බෙදීම 2 5යි. So මෙතන 10 බෙදීම 1 10යි. එතකොට ඍණ 5යි. ඍණයි ධන. අපිට එන්නේ ධන 5යි. හරි. එතකොට අපිට එන්නේ 5 වැඩි කිරීම 5 වැඩි කිරීම 5. ඒ කියන්නේ 5 සරප්පා 25යි 25 සරප්පා 225. ඍණ 5. ඍණ 5. Minus 4. Okay. So, and minus minus 5 into minus. Okay. So we will have 2 to 5. Okay. Then there is 2 this kind of charges. Okay. That means 450. Okay. Is that the answer? Zero. Calculate the total charges. Total charges means we have to add them together. No? 225 plus 225. It should be 225 plus 225. It should be 450. The answer is C. මේක අඩු කරන්න බෑනේ මේ charges කියනවා අඩු කරන්න බෑනේ අපිට නේද? So maybe they have considered this as one as a plus charges and another as a minus charges. I can't understand why they have done that this, okay? This is a plus charges and this is a minus charges. If this is plus and this is minus, then the answer will be zero. Okay. There are two cubes. No? This integration is only for one cube. Okay. Has Dr. Udesh done this question? Has Dr. Udesh done this question? Done this example? He said that no. Anyway, මම explanation එකක් හරි කරාද? කාට හරි මතකද? So our logic is correct, no? Uh, our logic should be correct, okay? Anyway, one charge cube is considered as plus and other charge cube is considered as minus. I can't understand why it is so, okay? So anyway, I will check it with Dr. Udesh, okay? And I will tell you what is the problem, okay? In next week, okay? I will check this with Dr. Udesh. I will ask from him, okay? Okay? Then we will clarify the problem, okay? So anyway, just let's move to other one quickly. This one, okay? Here, just try to get the idea, okay? The steps are correct, okay? These steps are correct, okay? Because you have to find the total charges, okay? So there is a function. So you need to volume charges, okay? Sorry, volume charges. So you need to do the volume integration, okay? So that is from 0, 1 to 0, 2, x, y, z, okay? Okay, anyway, we will try, we will see it later, okay? අපි බලමු අඩුතර මේකේ හරි උත්තරේද කියලා. Let's try to check whether we can get this, at least this one, okay? So what is the coordinate system? This include. This belongs to which coordinate system? So you have to use that coordinate system. First, you have to identify what is the coordinate system. What is this coordinate system? 4, 5 is it? What is that? Cylindrical or sphere? Cylindrical or spherical? Is this cylindrical or spherical? 4, 5 is it? Yes, that is cylindrical coordinate. Okay, so that is this is cylindrical coordinate. So you have to do the you have to use the cylindrical coordinates to evaluate the surface integration. Okay, so unit the charge distribution is given. Rho z rho square z square. Okay, so it is given rho square z square. Rho square z square. Okay, rho square z square. This is the volume charge. Okay, so you need to do the volume integration for QV. Okay, so this is a spherical coordinate. Okay, this is a spherical coordinate. So you need to do the volume charge with respect to spherical coordinate. So with respect to rho, with respect to 5, with respect to z. Okay, so you will have this function rho square z square rho d z d5 d d rho d5 dz. Okay, So you have to evaluate this integration. Okay. Rho d rho dz. Here rho is there. Okay. Rho d5. D rho dz. Rho d5. So rho is there. Okay. So this rho is there. This rho is there. So and the limit are also given. Limits also given. Limits from 0 to 0, 1, 0 to 5, 2 to 4. 0 to 0, 1, 0 to 5, 2 to 4. Okay. So rho is from 0.1 to 0.2, 5 from 0 to 2, 5, Z from 2 to 4. Okay. So limits are also given. So very easily you can evaluate. Okay. So if you consider uh, uh, rho, okay, d rho. So rho into rho is square. So you will have rho to the power 3 from 0, 1 to 0, 2, d rho. What is the answer? Rho 4 divided by 4. So what is the answer? 0.24 minus 0.14 divided by 4. So you will have an answer here. Okay. Then you need to evaluate it with respect to uh, 5, d5. Okay. 5. 5 is from 0 to 2, 5. So you need to evaluate it with respect to d5. So this rho and z are constant with respect to d5. So you will have only 5. That is from 0 to 2, 5. So the answer is 2, 5. Okay. Then you need to evaluate with respect to z. Okay. So z square is there. Z square dz. Z is from 2 to 4. Okay. So you will have uh, z to the power divided by 3. This is from 2 to 4. Okay. So you will have 4 square 4 to the power 3 minus 2 to the power 3 divided by 3. Okay. And you have another answer here. Okay. So what is the value? What is this value? And what is this value? Check whether we get this what? Sorry, here this is from 0 to 0, 1. Okay. This is from 0 to 0, 1. This is from 0 to 0, 1. Okay. This is from 0 to 0, 1. That means 0, 1, 4 minus 0. Okay. 0.1 into 4, 4 minus. Okay. Others are okay, no? 5 from 0 to 5, 2 to 4. Okay. Check whether we get this one. Sorry. Sines 0.65 also there. Okay. This term is also there. Okay. So when you do the integration, I'm sorry. Okay. When you do the integration with respect to 5, this is not correct. Okay. This is not correct. You have to integrate 5 term is also there. I didn't see 5. That is sine 0.65. You need to integrate with that one. Sine 0.65 d5. This is from 0 to 25. Okay. So sine 0.65, once you integrate, you will get minus cos 0.65, okay, divided by 0.6. No, suppose this is the value. Okay. So you need to apply 0 to 25. Please find this answer. Then you have to. So here we have answer. Here also we have answer. Here also we have answer. The total volume will be X, Y, Z. This answer, and this answer. Okay. So check whether this is 1, 0, likewise. We get that one. Okay. So check it later. Okay. Check it later. So try to do this by yourself. Okay, correctly. If there is any problem. Okay. Okay. Uh, and here another one is given universe. So what is mean universe? Universe means the infinity maybe. Maybe infinity. Okay, I don't know. Maybe infinity. Okay. So this is given in spherical coordinate. Okay. This should be in spherical coordinate. So they are talking about infinite spherical maybe. I'm not sure. Okay. Infinite spherical. That means 5 from 0 to so you will get the yeah maybe correct. Okay. So 5 from 0 to 25. No. ඒක infinite වුණා කියලා 5 0 to 25 ම තමයි. Theta is 0 to 5. It is not changing. But R will be changing. It will be 0 to infinity. 0 to infinity. Okay. So you will have this one, e to the power minus 2R divided by R square. Okay. Then R square sin theta, d theta, d5, dz. Definitely you will get the constant value y. This R square cancel out. Okay. Then you will get e to the power minus 2R. So e to the power minus 2R. Okay. E to the power minus 2R means like this. Okay. This is the function. This function. Okay. E to the power. So e to the power 0 means it is 1. E to the power 0 means the value is 1. Here the value is 1. Okay. And once it go to the infinity, what happened? This e to the power 2 0 will become 0. Okay. So this will be 0. Okay. This will become 0. So you will so the R value, the once you so once you integrate with respect to R, you will get a finite value. Okay. Finite value, because if you integrate this one, for example, if you integrate this one e to the power minus 2R, 0 to infinity, dr, what is the answer? E to the power minus 2R itself divided by minus 2. Why this minus 2? I am not sure about this minus 2, because if we have a minus value, maybe from others that minus may be cancelled. Okay. So I think it is better if we have plus here. Okay. No, if it is plus, it will not constant value, finite value. Okay. Anyway, it should be minus. Okay. So minus 2. Okay. So this is from 0 to infinity. So what is the value? So minus half is there. E to the power 0 means e to the power infinity means 0 minus 1. So you will have half. Correct? You will have half here. Okay? You will have half here. Okay, you will have half here, no? Is that clear? Because the e to the power minus like this, e to the power, this is exponential. This is exponential minus exponential function. Okay, e to the power minus 2R. This is the minus exponential function. This is R. Okay, so when R is 0, this will be 1. When R is infinity, this is goes to 0. Okay, so e to the power minus to infinity means 0. E to the power 0 means 1. 0 minus 1. So you will have minus 1. Here you will have minus half to minus 1. You will have half. Okay. So that is very easy. If you have ඔකට තේරෙන්නේ නැත්නම් අහන්න මම මේ ටක් ගාලා කරගෙන යන එච්චර අමාරු ඉන්ටග්‍රේෂන් නෙවෙයි හින්දා මේවා හරි අමාරු ඉන්ටග්‍රේෂන් නම් මටත් කොහොමදත් කරන්න බෑ ඇත්තටම ලේසියින්ද තමයි මේ කරන්නේ හරි මටත් මතක නැහැ හැම ලොකුවට ඉන්ටග්‍රේෂන් ඔය මේ ආදේශ දදා එහෙම කරන්න එහෙම ඒවා එන්නේ නැහැ ගණන් වලට හරි බය වෙන්න එපා හරි මේ වගේ සරල ඉන්ටග්‍රේෂන් එකක් ඒ කියන්නේ සාමාන්‍යයෙන් අපිට කරගන්න පුළුවන් ඉන්ටග්‍රේෂන් එකක් තමයි එන්නේ අපි මැත්ස් නෙවෙයිනේ හරි here we are not going to evaluate your mathematical knowledge okay we need to check whether you can apply mathematical concept to solve engineering problem. Okay, so that is the main task here. Okay, so we need to verify whether you can apply the mathematics concept to find the solution for engineering problems. Okay, so here we have engineering problems. We need to find the charges. Okay, that is an engineering problem. So we are using maths to solve that problem. Okay. So in this course, definitely you will not be evaluated. The maths knowledge will not be evaluated. Okay. But you should know the application. You should have the idea about the application. Okay. මේ පොඩි පොඩි සුළු කිරීම වුණාට ඉන්ටග්‍රේෂන් එක වැරදුනා කියලා ඔකට්ටියට ලකුණු නැති වෙන්නේ නැහැ හරි. ඔකට්ටියට හරියට තියරි එක ඇප්ලයි කරලා තියෙනවා නම් ලකුණු තියෙනවා. හරි. හරි. කොහොමද මම කියන්නේ. එහෙම තමයි අපි පේපර් එක බලන්නේ හරි. ඕකේ. මොකද ඔකට්ටියට මැත්ස් මේ ඉන්ටග්‍රේට් කරන්න පුළුවන්ද ලිමිට් මේ මොකක්ද මේ සයින් ඉන්ටග්‍රේට් කරන්න දන්නවද එක්ස්පොනෙන්ෂියල් ඉන්ටග්‍රේට් කරන්න දන්නවද ඒව නෙවෙයි බලන්නේ හරි හැබැයි මේවා නම් ඔකට්ටියට මතක තියෙන්න ඕනේ මේ වගේ සරල ඉන්ටග්‍රේෂන් ඔකට්ටියට තියෙන්න ඕන හරි ඔළුවේ මොකද ඔකට්ටිය මැත්ස් කරලා තියෙන හින්දා okay okay so I think we can evaluate this one or then you need to evaluate from so we have evaluate one okay using R we have evaluate, then we have to evaluate from d theta maybe. Okay, so there is no any theta value here. Sorry, sine theta is there. So you will have minus cos theta. Okay, so once you apply it from 0 to 5, what is the value you will get? Minus is there, cos 5 is minus 1, minus cos 0 is again 1. So you will have 2. Okay, you will have 2. Now, once you integrate from D5, what is the answer you get? If you integrate this from D5, what is the answer? This function with D5, what is the answer? From 0 to 25, what is the answer? Quickly, you can tell me, what is the answer for this? මොකක්ද answer? ඔකට්ටියට මේ ඉන්ටග්‍රේෂන් හිමීට කරන්න ඕන නම් කියන්න. හරි මම ඒක හිමීට කරන්න. මම මේ ඔකට්ටියේ කාලය ඉතුරු කරන්න ඕන හින්දා තමයි ඉක්මනට කරන්නේ මේ ඕන නැති ඒ කියන්නේ. ටක් ගාලා මේ වගේ ඒවා කරගෙන යන්න. මොකද කියන්නේ? මොකද මෙතන උත්තරේ? What is the answer? D5 වලින් කරපුවා මොකක්ද වෙන්නේ? යුනිවර්ස් කියන්නේ ඉන්ෆිනිටි තමයි. හරි යුනිවර්ස් කියන එක ගෝලයක්නේ. ඒ කියන්නේ මේ කියන්නේ විශ්වය. විශ්වය කියන්නේ ගෝලයක් විදිහට සලකන්නේ නේ. එතකොට ඒ කියන්නේ ඒක ඉන්ෆයිනයිට් ගෝලයක්. හරි. එතකොට අපේ concept එක හරි අපේ මේ evaluation එක හරි අපි හදපු විදිය. යුනිවර්ස් කියන්නේ ඉන්ෆිනිටි කියලා හිතන එක හරි. මේ යුනිවර්ස් කියන්නේ යුනිවර්ස් එක. ඒ කියන්නේ මොකද්ද? විශ්වය කියන එක. Okay. So that is a infinite sphere, no? Universe is a infinite sphere. මේක තේරුන්නේ නැද්ද මේ? ඔකට මේකට ටක් ගාලා උත්තර කියන්න පුළුවන් වෙන්න ඕනනේ. 5 වලින් අනුකලනය කරපුවාම. එතන මොකොත් 5 වල නැහැ නේ කැලල. මම ආපහු ලියන්නද ඒක? මෙන්න මේක තමයි දීලා තියෙන ෆන්ක්ෂන් එක. හරි. Yes, that is the answer. Okay, anyway, you only you are giving the answer. Okay, others are muted. Okay, so anyway, I will explain it quickly again. Okay, so we are not doing many. So we are doing some basic things here. Okay, so so the charge distribution is given. Charge distribution is given. That is e to the power minus 2r divided by r. Okay, and you are asked to find the this is the trans distribution. Okay, so you are asked to find the trans distribution within the universe. Okay, what is universe? It is an infinite sphere. It is an infinite sphere. So if it is an infinite sphere, uh, if you consider infinite sphere like this, okay. So there are r is there, theta is there, theta is in this direction, and 5 is there, 5 is in this direction. XY plane, okay. This is y, this is x, and this is z. So theta is in ZY plane. This is theta. 5 is in XY plane. Okay. So to have a sphere, definitely theta should be from 0 to 5. Okay. And 5 should be from 0 to 5. But this is a universe, infinite sphere. To have a sphere, these limits are should be there, no? If these limits are changed, it will not be a sphere. හරි? මේ limits තියෙන්න ඕන ඒක සම්පූර්ණ ගෝලයක් වෙන්න. සම්පූර්ණ ගෝලයක් වෙන්න නම් මේ limits තියෙන්න ඕන. This limit should be there. Okay? එහෙම නැත්නම් හරි? හරි. මේක infinite වෙන්න නම් මොකද්ද වෙන්න ඕන? මේ r කියන එක infinite. R should be infinite. But r is starting from here, 0. 0 to infinity. There is no limits for r. Okay, so this r will be 0 to infinity. First thing, you should understand this parameter with respect to universe. Okay, first thing, you need to understand these parameters with respect to universe. To have a sphere, we should have this one. To have an infinite sphere, we should have this one. Okay, I think that is clear. Okay, now you need to do the volume integration. Volume integral using spherical coordinate. To use spherical coordinate, okay, it will be r square sine theta dr d theta d phi. Okay, the r square is there. How? Why r square is there? Don't worry. Okay, just keep this in remember. Okay, this is a sphere. Dr is okay, no problem. But d theta is with r, so r d theta. D phi is with r sine theta. So r into r square sine theta, dr d theta d phi. Okay. Okay. So we have to use this one. Then your distribution, charge distribution, that is actually this is not charge distribution. I'm sorry, this is charge density. Okay. This should be charge density. I'm sorry, okay. This should be charge density. This is not the charge distribution. Distribution, I don't know. Anyway, this is charge density. Okay. So you need to do this. You need to integrate this charge density with respect to this. Okay. So now R square cancel. Okay. Now you need to put limits. Okay. For R, limit will be 0 to infinity. For 5, limit will be 0 to 2, 5. For theta, limit will be 0 to 5. Okay. Now, first we consider this with respect to dr. Okay. So you can see that only R is here. Only R is here. There is no d theta and d phi. Okay. So first we consider, okay. So first we consider this one, integration with respect to dr. Okay. With respect to dr. Okay. So with respect to dr, sine theta is a constant. So we can ignore the sine theta. And this is only the variable. So it will be e to the power minus 2r 0 to infinity dr. Okay. So as I told you, we will have e to the power minus 2r divided by minus 2. Okay. So you will have minus half. Okay. So e to the power infinity, it will be 0. E to the power 0, it will be 1. Okay. So 0 minus 1 minus 1. Minus into half, you will have half. Okay. Now you are considering theta. Theta. Okay. So if you consider theta, okay, this is a constant. So you can ignore this. Okay. So this will be not there. And this is the variable sine theta. Theta is there. Okay. So you have to integrate 0 to 5 sine theta d theta. Okay. So very quickly you can get the answer minus cos theta. So it will be minus cos 0, cos 5, that is minus 1, minus cos 0, that is 1. So you will have 2 plus 2. Okay. Now you need to consider it with respect to what? D5. Okay. So if you consider D5, this is a constant, you can ignore it. This is a constant, you can ignore it. Okay. So there is no D5. Okay. So you will have only D5 here. That means only one is there. 0 to 2, 5. Okay. So if you integrate 1, it will be 5. No, it will be 5. If you integrate 1 with respect to dx, answer is x. If you integrate x with respect to ds, answer is s square by 2. Okay. So you will have 5, that is from 0 to 5. So you will have 2, 5 into 0. Okay. 2, 5 is there. Okay. Now you have the total, the universe charge, the universe total charge Q will be half into 2 into 2, 5. So total charge will be 2, 5. Okay. So 5 is 3.14 or something, no? 5 is, as I can remember, it is 3.14. මේක දෙකට බෙදලා නෙමෙයි කිව්වේ මට මතක හැටියට 3.14 තමයි. හරි 22කින් 4නේ 22 බෙදීම 4නේ. ඒ කියන්නේ 3.21යි 10යි 10ට 1යි 7යි 30ට 4යි 28යි 3.17. 25 3.17 වගේ දෙක නෑ. ඒ කියන්නේ 6.28. හරි මේ ආන්සර් එක හරි. මේ ආන්සර් එකත් හරියන්න ඕන. ඔකට ඉවැලුවේට් කරලා බලන්න. මෙන්න මේක තමයි පොඩි ප්‍රශ්නයක් තියෙන්නේ. ඒක පොඩ්ඩක් උදේශ සර්ගෙන් තමයි අහගන්න වෙන්නේ. හරි. මම පොඩ්ඩක් ඒක උදේශ සර්ගෙන් අහන්නම්. හරි. හරි. අපි මට මේ line charges වල පොඩි ගාණක් හදන්නත් ඕන. හරි. මොකද කරන්නේ දැන් already 8 o'clock. Okay. ටක් ගාලා line charge වල ගාණක් හදමුද අපි? නැත්තම් නතර කරලා ළමන සතිය කරනවද ඔය කට්ටිය පොඩ්ඩක් මේ අවුල් නම් ඔකට මම කියන්නේ මම කරන විදිහ අප්සෙට් නම් පොඩ්ඩක් කියන්න. මේ මම අර ඔය කට්ටිය කියන්නේ මැත්ස් ඇත්තට වැඩි බර වෙන්නේ නැතුව ටක් ගාලා මේ අර මේ කියන්නේ අපි අර අපිට අවශ්‍ය ඇප්ලිකේෂන් එක කවර් වෙන විදිහට කරන්නේ. Okay, we will do one question with line charge also quickly. Okay, with respect to line charge. Okay. Uh, okay. So if you consider line charge means that is a line goes to infinity. Okay, that is a line goes to infinity. That is the line goes to infinity. Okay. So, if you are given any line charges, okay. So normally it is in rho L. Okay, this is the line charge rho L. Okay, rho L. Okay. So if you consider this, okay, if you consider this for example, let's say that this line charge is in z-axis. This line charge is in z-axis. Okay, this line. Just try to understand the concept here. Okay. So now you have a line charge here. මොකද මේකෙනුත් ගණන් දෙයි සර් එක්සෑම් එකට. මම මේ ගණන් දෙන ඒවා වගේ විතරයි හදන්නේ. හරි. සාමාන්‍යයෙන් එක්සෑම් එකට එයි කියලා හිතන ගණන් තමයි හදන්නේ. සර්ට මම කියනවා කොහොමද මේ ගණන් තමයි හැදුවේ කියලා. හරි. මේ ගණන් හදන්න ගියාම මටත් පැටලෙනවා ඇත්තටම මේකේ දැන් මෙතන මේ තියෙන්නේ වොලියුම් charge එකක් හින්දා ඇතිවන ෆීල්ඩ් එක. හරි වොලියුම් charge එකක් හින්දා ඇතිවෙන ෆීල්ඩ් එක. එතකොට මේ වොලියුම් charge එක දැන් මේ r dash කියලා අරන් තියෙන කොතන හරි මොකක් හරි තැනක පොයින්ට් එකක්. හරි. ඒ පොයින්ට් එකක් අරගෙන r කියන්නේ සාමාන්‍යයෙන් අපේ අර ස්පෙරිකල් එකේ r මයි. හරි. r dash කියන්නේ වෙන කොතන හරි එකක්. හරි වෙන කොතන හරි පොයින්ට් එකක්. එතකොට දැන් ඒක හරියට මෙහෙමයි. හරි. හරි. එතකොට මොකක් හරි පොයින්ට් එකක් සලකලා තියෙනවා. මෙතන ඉඳන් දුර තමයි r dash කියලා ගන්න. හරි r dash කියලා. හරි. කරලා මෙතන මේ වොලියුම් charge එකක් හින්දා ඇතිවන කොතන හරි තැනක ඇති වෙන මේක තමයි මේ ඉලෙක්ට්‍රික් ෆීල්ඩ් එක තමයි මේ හොයලා තියෙන්නේ. හරි. එතකොට දැන් මේක ඇප්ලයි කරන්න යනකොට ටිකක් අමාරු වෙනවා. හරි. මොකද මෙතන අපිට අර වෙක්ටර් පොඩ්ඩක් සලකන්න වෙනවා අර යුනිට් වෙක්ටර් ඩිරෙක්ෂන් එක ඒවා ටිකක් සරකලා ගන්න වෙන්නේ. හරි. අනිත් එක ඒ වගේ එක්සැම්පල් මෙතන හදලත් නැහැ. හරි. ඒක හින්දා හුඟක් වෙලාවට මෙතනින් ඔය කට්ටියට ගාණක් දෙන්නේ නැති වෙයි. හරි. ඒකයි මම මේක ස්කිප් කරේ. හරි. ගාණක් දෙන්නේ නැති වෙයි. හැබැයි ලයින් charge එකේ ඊට වඩා concept එක ටිකක් සරලයි. හරි. You can understand it very quickly. Okay, very easily. Okay, I will okay. So I will just try to explain it quickly and do one question. Okay. So if we have a line charge, let's say that you will have this one. Okay. Okay. This is Z, this is Y, this is X. Let's say that your line charge is in the x-axis, z-axis. The line charge is in the z-axis. Okay. So if you consider any So this is go to infinity, okay? Don't forget, this is go to minus infinity to plus infinity. So when you are finding, if you are given a specific point, okay, if you need to find the total charge here, total E field here, okay, so these are very small points now, okay, all these small points, there are some electric uh, fields are generating like this in this point, okay, there are several electric fields are uh, generating in this point, okay. To find the total one, you have to get the resultant one. These are some forces, no vectors, no. So you have to get the resultant forces. Okay. You have to get the resultant forces. Okay. So this is infinity, no. Okay. So all these one are symmetrical and all these forces are also symmetrical. Okay. So maybe you can understand practically think. Okay. Don't think in mathematical. Okay. But practically things, these are normally symmetrical because this is infinite length. Okay. So, uh, so most probably, okay, your total E field will be in this direction. Okay. So if it is in Z axis, okay, your total uh, direction will be your total resultant E field will be in this direction. Okay. So what is this direction? So if you consider this is Y direction, if you consider this one, that is also Y direction. Okay. If you consider මේක දැන් මෙහෙමනේ තියෙන රවුම කොහොම තියෙන රවුම හරි දැන් මේක Z හරි මේක Y මේක X හරි දැන් අපි මෙන්න මේ පැත්තේ ඒවා පාවිච්චි කරොත් එහෙනම් මේ පැත්ත ගත්තොත් හරි මේ පැත්ත ගත්තොත් හරි ඒක X direction is Y direction මේ minus Y direction මෙන්න මේ පැත්ත හරි මේ පැත්ත හරි ගත්තොත් එහෙනම් මේක X direction that is X direction but if we consider this point maybe here what is this direction? What is this direction? This is a cylinder. Z axis is this, okay? Make it is coming out from the screen, okay? And your X axis will be this, and your Y axis will be this, okay? Now make it X axis, Y axis එක වගේ පේන්නේ. හැබැයි Y axis එක නෙමෙයි. මොකද මෙන්න මේ ඕනම තැනක වෙන්න පුළුවන්. මේ කොතන බැලුවත් E field එක තියෙන්නේ මෙයාගේ මේ පැත්තට වෙන්නේ. අංශක 90ක් මේ පැත්තට. හරි? What is this direction? මේ direction එක මොකද්ද? Tell me. I think you know this direction. You can tell if you have the. So you can't tell that direction maybe using X, Y, Z. But using another spherical coordinate, you can tell this direction. What is that? Using another coordinate. Don't use spherical coordinate. Sorry, don't use rectangular coordinate. Okay. If you use another there is another one, no, spherical and cylindrical coordinates. Okay. So you can give this direction using spherical or cylindrical coordinates. What is this? No, it is not theta. It is not theta. This is just like a cylinder, no? If it is just like a cylinder, what is the easiest coordinate system you should use? This is just like a cylinder, okay? So, තේරෙනවද මේ axis දිගේ මේ වටේට මම බලන්නේ. මෙන්න මේ වටේට මේ වගේ තැනක බලන්න මෙහෙම. මෙන්න මේ කොහේ හරි තැනක E field එක බලන්න. මෙන්න මේ කොහේ හරි තැනක E field එක. එතකොට මේක මොකද්ද? මෙයාගෙන් ස්පෙસિෆික් දුරකින් තියෙන තැනක. මෙයාගෙන් නම් ස්පෙසිෆික් දුරකින් තියෙන තැනක. එතකොට මොකද්ද මේ? It is not theta. ඊට ඩිරෙක්ෂන් එක කියන්නේ ඇත්තට මේක. මෙහෙම z තියෙනවා නම් මේක y නම් මේක x නම් අපි ස්පෙරිකල් කෝඩිනේට් එකේ r කියන එක මෙහෙම ගත්තොත් මොකක් හරි පොයින්ට් එකක් ගත්තොත් එහෙම හරි මේ මොකක් හරි පොයින්ට් එකක් මෙතනින් නම් මේ පොයින්ට් එකට තියෙන දුර තමයි r. ඊළඟට මේ z axis එක හදන කෝණය තමයි θ. ඊළඟට මෙන්න මේක ප්‍රොජෙක්ට් කරපුවාම xy ප්ලේන් එකට මෙන්න මේ හදන කෝණය තමයි phi. එතකොට මේ කෝඩිනේට් තුන තමයි ස්පෙරිකල් කෝඩිනේට් r θ phi. r θ phi. එතකොට මේ θ නෙවෙයි. θ කියන්නේ z axis එකක් හදන එක. එතකොට මේක z axis එකක් හදන නෙවෙයි මේ තියෙන්නේ. මෙතන කෙලින්ම මේ z axis එකට සමාන්තර එක 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 දුර කියන්නේ z axis එක වටේ යන තැන තියෙන්නේ. එතකොට මොකද්ද මේ? දැන් අපි සිලින්ඩරිකල් කෝඩිනේට් එක ගත්තොත් මොකද්ද මේ? අපි දැන් මෙහෙම තියෙනවා z, මෙහෙම තියෙනවා y, මෙහෙම තියෙනවා x. හරි. එතකොට අපි මේකේ සිලින්ඩරයක් විදිහට හිතන්නේ මෙතන. මෙන්න සිලින්ඩරිකල් කෝඩිනේට් එක අපි හිතන්නේ මේක සිලින්ඩරයක් කියලා. ස්පෙරිකල් කෝඩිනේට් එක අපි හිතන්නේ මේක ස්පියර් එකක් කියලා. රෙක්ටැන්ගියුලර් කෝඩිනේට් එක අපි ඒක හිතන්නේ ඝනකාභයක් කියලා. Okay. So if we take a spherical, sorry, cylinder, any point in a cylinder, okay, can be defined using three parameters again. Okay. So one thing is z-axis to this distance. Z-axis to this distance. That is normally referred as rho. Okay. Okay. And the z-axis value, this value, z-axis value, that is z. Okay. And also, තඩි වල ලියන්න. ඔකට මේ coordinate system හරියට ඔලුවට වැටලා නැද්ද තාම? lateral entry කට්ටියට නම් ඕක අමතක ඇති. හරි? maths එකම ඔකට මොඩියුල් කරන්නේ නැහැ නේද? maths මොඩියුල් දැන්. lateral entry කට්ටිය maths මොඩියුල් මොනවා හරි කරනවද? එතකොට lateral entry කට්ටිය නම් මේවා ඉගෙනගෙන ගොඩක් කල් වෙන්නේ නැති. හරි? එතකොට ඒ කට්ටියට මේවා අමතක වෙන එක සාධාරණයි. එතකොට අනිත් කට්ටියට සාමාන්‍ය මට්ටමකට මතක තියෙන්න ඕන ඇත්තට. මොකද මේවා ඉගෙන ගත්ත වෙන්න ඕන ඔය කට්ටිය. හරි? මේවා maths වලට ඉගෙන ගන්නවා මේ coordinate system. If we consider this kind of cylinder, okay, so any point of this cylinder can be defined using the distance from Z. Okay, this is referred as rho. Okay, and this point also can be defined. Okay, using the distance in Z axis, that is normally as Z. Okay, and also you have, when you are considering this one, okay. දැන් මේක තියෙන තැන. ඒ කියන්නේ මෙන්න මේ ස්පිරිකල් එක දැන් අපි මෙන්න මේ වගේ පොයින්ට් එකක් ගත්තොත් එහෙම හරි. දැන් මේක උඩින් බැලුවොත් එහෙම හරි. මෙහෙම උඩින් බැලුවොත් එහෙම කවුරු හරි හරි. මේක මෙහෙම තියෙනවා හරි. මෙහෙම තියෙනවා y, මෙහෙම තියෙනවා x. හරි. මෙහෙම උඩට එනවා z. හරි. මෙහෙම උඩට එනවා z. හරි. මේ y, මේ x. හරි. දැන් එතකොට මෙන්න මේ වගේ පොයින්ට් එකක් ගත්තොත් හරි. මේ z axis එකේ දුර මෙතෙන්ට තියෙන දුර තමයි z කියලා ගත්තේ. මෙතන බිඳුවේ ඉඳන් z තියෙන දුර z. හරි. ඊළඟට මෙතන ඉඳන් මේ තියෙන දුර තමයි රෝ කියලා ගත්තේ. හරි. ඊට පස්සේ ඔකටට පේනවා ඇති දැන් මේකේ මොකක් හරි ඇන්ගල් එකක් ගන්න වෙනවා අපිට. මෙතන පොසිෂන් එක කියන්නේ. මේ හරියට පොසිෂන් එක කියන්නේ. ඒක තමයි මෙතනින් කියන්නේ θ වල. නෑ ෆයි වල. සෝරි. එතන මේක මෙන්න මේ පොයින්ට් එක මෙන්න මේ x axis එකත් හදන කෝණය තමයි ෆයි කියලා. හරි. එතකොට ඒ coordinates තුන තමයි අපි use කරන්නේ මෙතන මේ සිලින්ඩරයක් උඩ පොයින්ට් එකක් නිරූපණය කරන්න. හරි. rho phi z. හරි. එතකොට මේ දුර අපිට සිලින්ඩරිකල් කෝඩිනේට් එකකින් කෙලින්ම කියන්න පුළුවන් මොකද්ද මේ දිශාව? මේක rho දිශාව. rho දිශාව. හරි. නේ මෙන්න මේ දිශාව රෝ. හරි. ඒ කියන්නේ යුනිට් වෙක්ටර් එක ඒ රෝ. හරි. So, so that is very important. Okay. That is very important because when you are doing when we are doing question, this understanding is very important. හරි. මෙයා මට හරියට අඳින්න අමාරුයි. හරි මෙයා පොඩ්ඩක් බලන්න ඉන්ටර්නෙට් එකේම ඇති මේවට හොඳට ඩයග්‍රෑම්ස් එන්න දාලා. මම පොඩ්ඩක් බලන්නම් අර විශාලගේ මේ නෝට්ස් වගේක් තිබ්බා. ඒ ටික තියනවාද කියලා. ඒ ටික තිබ්බොත් මම ඒ ටික දාන්නම්. ඒ ටිකෙත් මේ ටික පැහැදිලිව තියෙනවා. මේ ඔය පොත්වල එහෙම තියෙනවා හැබැයි. හරි. මෙයා මේ සෑහෙන පරණ ඒවා බේසික් දේවල් මේ. හරි. So what I want to tell you is that okay, if we place that line integral with respect in the z direction, okay, so the any point E field can be defined in rho direction, okay, that is a rho direction, okay. So any E field is depending the distance from this one, okay, that distance is rho, okay. So E is defined as 1 over 4 5 epsilon rho. This is one rho. This is that length rho into a rho. Okay. So this should be rho square. No? Okay. So this is the E field generated by a line charge. Line charge. Okay. Line charge in any point. Okay. It is in cylindrical coordinate. Okay. Don't forget this is in cylindrical coordinate. Okay. Now. So here it is, sorry, here it is rho, no? Not rho is it is rho, sorry. Okay. So this will be rho, okay? This will be rho. Because when you are getting the so as I told you here, you need to evaluate the resultant E field, okay? So once you evaluate the E field, okay, this will be rho, okay? This will be rho, okay? And the charge density is also there. This is the charge density, rho L. Charge density, 4 5 epsilon rho, A rho. This is in cylindrical coordinate. Okay. So this is the distance to the point. Okay. Distance to the any point. Okay. This is the radial distance. Normally this is referred as radial distance to any point. To a point, which we need to calculate the E field. Okay. Okay. So I will quickly do one question. Okay. Maybe this one. Okay. Make හදුවද මේ ගාන උදෙස්සර. මේක මේ මෙතනම තියෙන ගානක් මේක හදුවද උදෙස්සර. අංකල් කියන්නේ හදුවද කියලා? Please tell me whether Udesh sir has done this one or not. Udesh sir කිව්වා example කරේ නැහැ theory විතරයි කරේ කියලා. හරි. ඒ වුණාට සමහරට අමතක වෙලා හරි කරලත් දන්නේ නැහැ ඒකයි. Udesh sir හදුවද මේ ගාන? Has Dr. Udesh done this question? Oh, ඔකට තේරෙනවද මං කියන එක? මට හරියට අඳින්න බෑ මේ මෙහෙම මට චිත්‍ර අඳින්න බෑ ලස්සන. හරි. ඔකට අර පොඩ්ඩක් ත්‍රිමානව හිතලා ඔලුවට ගන්න ඕන මේක. හැබැයි ත්‍රිමානව හිතලා ඔලුවට ගත්තොත් එහෙම ඔක්කොම එක වගේ. හරි. ඔක්කොම එක වගේ. ඔක්කොම එකම දේ තමයි කරන්න තියෙන්නේ. එකම දේ අර නිකන් බේසික් ඔය පයිතගරස් ප්‍රමේය දදා තමයි හදන්න තියෙන්නේ. අමුතු දෙයක් කරන්න නැහැ. මේ ගාන හදන්න මොකද කරන්නේ? නිකන් මම මේ ගාන කියන්නම් හදන හැටි. හරි. මම මේක කියලා තියෙනවා. හරි. මේක කියලා තියෙනවා before naming inductor infinite line and එකට කියලා තියෙනවා consider කරන්න කියලා just consider the infinite line charge parallel to z axis. Okay, so that line charge is parallel to z axis. This is z, this is x, this is y. Okay, so this line charge is parallel to z axis. Okay, it is parallel to this z axis. Okay, so line charge should be maybe like this, so like this. Okay, and the x and y axis are given, x and y coordinates are given. Okay, so that is 6 and 8. X is 6, sorry, this is y and this is x. Okay, x is 6. Then make electromagnetic වල නම් මේක පොඩ්ඩක් පැටලුණාට කමක් නැහැ. හරි. හැබැයි ඕක හරියට මේව කරගන්න මොකද ඇන්ටනා වලට එහෙම එනකොට ඕක හරියටම මේව කරගන්න ඕනේ. මොකද මේවා වරද්දාගත්තොත් එහෙම ඔක්කොම හරි. අර ඔරියන්ටේෂන් අනම්මනම් ඒව බලනවා. දැන් මේ වගේ එහෙම එහෙම ප්‍රශ්නයක් වෙන්නේ නැහැ මෙතන. හරි. Z, ZY, ZXY. Okay. And X is 6. X is 6. Y is 8. X is 6. Y is 8. 6, 8. And මෙතන තමයි යන්නේ. Charge. This is the line charge. Line charge is keeping in this one like this. This is goes to infinity and here it goes to infinity. This is a line charge. Okay. Now they asked to find the E at the general point X, Y, Z. Okay. So any general point you can consider. That is X, Y, Z. Any general point you can consider X, Y, Z. Okay. So now you are asked to find the E field at this one. Okay. So E field is given for L, for 5, epsilon, rho, A rho. Okay. So this is in spherical, sorry, cylindrical core. This is in cylindrical core. Now the XYZs are given. Okay, so that means this is in spherical, rectangular coordinate or Cartesian coordinate. Okay. So that means we have to do a conversion. Okay. Okay. Now the idea is there. Okay. So you can consider a cylinder like this. Okay. Cylinder like this. Okay. From here to this point, that is 4. Okay, that is 4. Okay. So now you can, now what you have to understand is that you can see that if you consider any Z point, any point in Z axis, okay, so same value is there. Same value is there. Okay. If you can consider the Z axis, same value is there. Because it is parallel to Z. Okay. And it is goes to infinity. Okay. So this E field not affected to Z coordinate. For every Z coordinate, for every Z value, that means minus infinity to plus infinity. For every Z value, it will be not change. It will be a constant. Okay. Because from here to here, it will be a constant. Okay. But it is dependent on X and Y Z. If this X and Y Z are here, that means that point is here. X and Y Z are here, that point is here. X and Y Z are here, point here. Okay. So this E field is only depending on X and Y axis, X and Y coordinate, not in Z. Okay. Because this is radial. Okay. We have to consider the radial distance. Okay. That is why I told you that rho is a radial distance. Radial. Okay. Please try to understand this. Okay. It is very hard to explain this, okay? But you need to understand, okay? I will explain it again, okay? It is like this, okay? So If you consider this is y-axis, this is x-axis. Okay. Now your infinite line charge is fixed in here at 6 and 8. Okay. So this is z-axis. This is z-axis. Z-axis is in our direction. Okay. Z-axis in our direction. Okay. So now you consider, if you consider E field, okay. So this E field is like this. E field is like this. Okay. This is actually in this direction, arrow direction. Okay. Okay. Because this is rho. Okay. E field. Now you can see that, okay. If you consider this E field, okay. If we are going through Z axis, if we are going through Z axis, you are coming here and here, parallel to Z. So the distance from Z axis is not changing. That is, if you consider rho, that is rho. It is not changing. Okay. So if you are changing Z coordinate, this E field will not change. But what happens if we change X coordinate? For example, let's say that we take X8, Y10, maybe here. So distance is now different. Distance is now different. So this field is different than this field. But again, if we consider the field along this Z direction, again field will be constant. Okay. So what you understand is that, okay, if that if that line is parallel to Z axis, okay, so within the Z axis, at any Z axis point, E field will be a constant value. And E field is only depend on X and Y axis. Okay, that is the understand you should get. Okay. So now, if I want to calculate the radial distance, okay, if I want to calculate the radial distance, so you are now considering any point, okay, I will use this, okay. So you need to consider the Z axis. You have to consider only X and Y axis, okay. So now you are getting a common point, maybe here. This point is X, Y, Z. But Z is not applicable, okay? Because Z will not, because we are taking this radial distance, this is distance. This distance actually rho. This is the line charge. This is the point you consider. This is the line charge. This is the point you consider. So this rho is the radial distance. This rho is the radial distance. This rho is a radial distance. Correct? හරි. දැන් ඔකට කියන්නේ මෙන්න මෙතන line charge එක. හරිද? ඊට පස්සේ අපි මොකක් හරි point එකක් ගන්නවා XYZ කියලා. හරි? දැන් ඒ point එකේ දැන් ඔකට තේරෙන්න ඕන දැන් මේ Z තියෙන අපිට උඩට පල්ලෙහාට යන්නේ. එතකොට Z වෙනස් වුණා කියලා මේ row distance එක වෙනස් වෙන්නේ නැහැ. මේ Z අපි මෙන්න මේ point එක ගත්තොත් මේ Z වෙනස් වුණා කියලා මේ row වෙනස් වෙන්නේ නැහැ. row එකමයි. ඒකින්ද E field එක වෙනස් වෙන්නේ නැහැ. හැබැයි X හරි Y හරි වෙනස් කරොත් මෙන්න මේ point එක වෙනස් වෙනවා. මේක එක්ක එහාට යනවා, මෙහාට යනවා, එහාට කොහෙට හරි move වෙනවා. එතකොට මේ row කියන එක වෙනස් වෙනවා. එතකොට ඒක affect වෙනවා E field එකට. හරි. හරි. එතකොට අපි මේ radial distance එක ගන්නකොට, radial distance එක ගන්නකොට අපි ගන්න ඕනේ මෙන්න මේ distance එක. That is rho. That is actually identical to rho. What is that distance? This point is 6, this point is 8, and this is XY. Then what is this distance? It's like this, okay? If this is X, if this is Y, okay? You have a point here, okay? And you have, this is actually 6, 8 point. This is 8, this is 6, okay? Now you are getting another point, okay? Now you are getting another point. So this point may be X, and here it is Y. Now you need to calculate this distance, okay? To calculate this distance, you have to calculate this one and this one. This distance is X minus 6. This distance is Y minus 8. So if you square it, so this distance, radial distance is there, okay? So you can find the radial distance, that is x minus 6 plus y minus 8 is. මේක අනිත් පැත්තට ලියවා කියලා ප්‍රශ්නයක් නැහැ. ස්ක්වයර් කරපුවාම ධන ඍණ නැති වෙනවා. හරි? x minus square y minus x minus 6 square y minus 8 square. මේක 6 minus x උනත් කමක් නැහැ. 8 minus y උනත් කමක් නැහැ. හැබැයි ඒක වෙන්න ඕන. හරි? මෙයා 6 minus 8 6 minus x 8 minus y වෙන්න ඕන. එහෙම නැත්නම් x minus 6 y minus 8 වෙන්න ඕන. ඒක තමයි කරන්නේ. හරි? right. අපිට රෝ හෙව්. දැන් අපිට මේ a රෝ හොයන්න ඕන. මොකද a රෝත් අපිට a රෝ කියන්නේ මේ ඕලි. මේ මොකෙන්ද? මොකෙන්ද? මේ ඕලි. මොකෙන්ද කියන්නේ? spherical coordinate. Cartesian coordinate. හැබැයි a රෝ අපිට ගන්න බෑ. හරි? දැන් අපි හිතන්න මේක r කියලා. මේක r කියලා අපි ගත්තොත් එහෙම අපි මේ distance එක ගන්නවා ar කියලා radial distance. Radial direction. ar direction. හරි? එතකොට ar කියන්නේ unit vector එක. Direction එක. Unit vector එක හොයන්නේ කොහොමද? මෙන්න මෙයාගේ මුළු දිගින් r වලින් r මුළු දිග කියන්නේ vector එක බෙදනවා එයාගේ magnitude එක. r බෙදනවා magnitude එක. මේ විදිහට තමයි ar එක හොයන්නේ. එතකොට r කියන්නේ මොකක්ද? මෙයාගේ vector එක. ඒ කියන්නේ මෙතන ඉඳන් මෙතෙන්ට තියෙන vector දිග. vector දිග කොහොමද හොයන්නේ? How we can හරි? How to find the vector length? So vector length, okay? මෙතන ඉඳන් මෙතෙන්ට තියෙන vector length එක. Vector length එක අපිට හොයන්න පුළුවන්. දැන් මෙන්න මේ length එක. From here to here we need to find, okay? So it is equal to from here to here and here to here. Correct? මේක තමයි vector addition. Okay, this is vector addition. Okay. Okay. So this is y, this is x. Okay. Now your point is here, 6 and 8. Okay. Now you are considering any xy point, any arbitrary xy point. Okay. Any arbitrary xy point. This is x, y point. Okay. Now you need to find the vector distance from here to here, this distance, using the vector. Okay. Okay. So this point is x, this point is y. Okay. So vector distance, okay. So this is the vector actually. This is the vector in x-axis. And this is the vector in y-axis. If you add this x-axis vector to this y-axis vector, this is the resultant vector. No? That is the resultant vector. Okay. So this one is x and this one is minus 6. Okay. So it will be x minus 6. This is in the x direction. So it will be ax. So that is this vector. Okay. And if you consider this one, this is 8 and this is y. Okay. So from here to here, the distance will be y minus 8. Y minus 8, this distance, it is in this direction, ay direction. Ax and ay are the unit vector, okay? Ax direction, okay? So if you add this one to this one, you will have this resultant vector. That means you have to add this, okay? So that is the resultant vector, x minus 6 ax plus y minus 8 ay. So this is the vector. It should be divided by the magnitude of the vector. What is the magnitude of this vector? This one is squared by this one. Okay. So this is the length. Using the Pythagoras theorem, you can find the length. So it will be this distance, x minus 6 is square plus x minus 6 is square plus y minus 8 is square root. That is this length using Pythagoras. Okay. So that is that length. Okay. Okay. So now you have find AR as well as rho. Okay. So there is E is equal to 1 rho L for 5 epsilon rho A rho. Okay. So instead of A rho, you have to apply AR. So that is this. Instead of rho, you have to apply rho. That is this. It's that is also square root is there. Okay. Square root is okay. That is square root is there. Okay. So once that square root is multiplied by this square root, the square root will be cancelled and you will get this one. And the upper part will have this one. Okay. So that is the E. That E field is depending in AX and AY, X direction and Y direction. Okay. Not in Z direction. Okay. So that is the idea you should get. Okay. So try to do this example. Okay. Try to do this example as a homework. Okay. So next week we will try to do this example. Okay. Next week we will try to do this example. Okay. So if you have any problem, you can ask me. Okay. මම කරගෙන යනවා වේගෙ වැඩි වගේ නම් ඔකට කියන්න. මොකද පැය දෙකයිනේ තියෙන්නේ. පැය දෙක ටක් ගාලා කරන්නත් ඕන. ගණන් ටිකක් හදන්නත් ඕන ඒකයි. හරි. මම පොඩ්ඩක් සර්ට කියන්නම් මේ මම හදනවා වගේම ගණන් වලින් එක්සෑම් එකටත් දෙන්න කියලා. හරි. නැත්නම් ඔය කට්ටියට අමාරු වෙනවා වැඩේ. හරි. දැන් ඔය කට්ටිය මේක ගණන් හදනකොට පොඩ්ඩක් තියරි පැත්ත තමයි තේරුම් ගන්න ඕන. හරි. මොකද මේවා කෙලින්ම ඇප්ලයි වෙනවා ඇන්ටනා වලට. එහෙම කෙලින්ම ඇප්ලයි වෙනවා මේ. ඒතකොට ට්‍රාන්ස්මිෂන් ලයින් වල එක එක ඒවා අපිට ඩෙරිව් කරන්න. මේවා කෙලින්ම ඇප්ලයි කරන්න. හරි. ඒතකොට ඔකට පොඩ්ඩක් ඒක අන්ඩර්ස්ටෑන්ඩ් කරගන්න ඕන. අර කෝඩිනේට් සිස්ටම් සහ වෙක්ටර් කියන මැතමැටිකල්ස් කන්සෙප්ට් ටික කොහොමද අපි මේ වගේ එකකට ඇප්ලයි කරගන්නේ කියන එක. මේ වගේ ඉංජිනේරින් ප්‍රොබ්ලම් එකකට ඇප්ලයි කරගන්නේ කියන. හරි. So if you have any problem, you can ask. Okay. So wait for a moment. I will mark the attendance. Okay. So I think some student couldn't join at 6:30. Okay. So I think we have to move this from 7:30 to 9:30. Okay. So from next week we will do from 7:30 to 9:30, not from 6 to 8. Okay. So we have to start at 7:30 because some lateral students are there. Okay. So they are working. Okay. So they can't join. Most of them can't join at 6 o'clock. Okay. Because they have to travel and come to the home. Okay. So from next week, I will do it from 7:30 to 9:30. So do you have any concern with that time slot from 7:30 to 9:30? If you don't have any concern, I can ask update. I can ask to update the calendar. So what about you? What about others? Is this okay? 7:30 to 9:30? Okay, thank you. Okay, I think lateral entry student has no issue. Okay. So we will do. Okay. ඔකටට තේරෙන්නේ නැති දේවල් මොනවා හරි තියෙනවා නම් අහන්න. හරි. ඔය හදන ගණන් වල තේරෙන්නේ නැති මොනවා හරි තියෙනවා නම් අහන්න. සමහරට ඔකටට තේරෙන්නේ නැති වෙන්න පුළුවන්. Especially ඔය lateral entry කට්ටියට. හරි. මොකද ඔයා දැන් අමතකයි නෝ කට්ටියට. එතකොට මම එහෙම මෙහෙන් ඇඳ ඔය කියන ඒවා සමහරට ඔකටට තේරෙන්නේ නැති වෙන්න පුළුවන් නේ. ඔයා දැන් ඔකට අවුරුදු ගානකට කලින් කරපේවනේ. හරි. අපේ කට්ටියට සමහරට අමතක වෙන්න පුළුවන්. සමහරට මොකද අවුරුදු 4කට 5කට කලින් කරපු කට්ටියනේ. 3කට 2කට 3කට කලින් ඕවා කරලා තිබ්බනම් ඒත් අමතක වෙනවා. එහෙම ඕනේ නැහැ. දැන් ඇත්තම කියනවා නම් මේ මම දැන් ගිය සෙමෙස්ටර් එකේ ඇන්ටනා කරා. හරි. ගිය සෙමෙස්ටර් එකේ ඇන්ටනා කරා. ඔගේ ඇන්ටනා වල මම පළවෙනියටම කරන්නේ කෝඩිනේට් සිස්ටම්. කෝඩිනේට් සිස්ටම් උයි ඔය වෙක්ටර් ඔපරේෂන් ඔය ග්‍රේඩියන්ට් ඊට පස්සේ මොනවද තියෙන්නේ ඉතින් තව තියෙන ග්‍රේඩියන්ට්ස් තියෙනවා ඔය එක එක හොයන්න තියෙනවනේ හරි වෙක්ටර් වල එතකොට ඒව තමයි මුලින්ම කරන්නේ ඒ වුණාට ආපහු මේ ඉලෙක්ට්‍රොමැග්නටික් එකට දැන් ඔය සර් හදන්න කියනකොට මට ආපහු අමතකයි ඒවා. ඉතින් මමත් අර නෝට් එක බලලා තමයි මතක් කරගෙන කරන්නේ. හරි. එතකොට මම උගන්වන මිනිස්සයාට එහෙම අමතක වෙනවා නම් හරි. ඒ කියන්නේ නිතරම කරන එක නම මම නිතරම ටච් එකේ ඉන්නේ. මටත් ඔවා මතක තියාගන්න බෑ අමතක වෙනවා. හරි. දැන් ඔය කට්ටියට අමතක වෙනවා කියන එක සාධාරණයි. ඒකින්ද මොකක් හරි බැරි දෙයක් තියෙනවා නම් ඕන වෙලාවක අහන්න. හරි. තේරෙන්නේ නැති තැනක් තියෙනවා. හරි. මේ සමහර ඒවා දැන් අර ගාන එහෙම දැන් මටත් තේරුන්නේ නැහැ නේ. අර දැන් අර අපි හදන්න ගත්ත ගාන අරක කොහොමද එකට එක කැපිලා යන්නේ කියන එක. හරි. ඒ වගේ දේවල් අපිට උදේස් සර්ගෙන් අහලා හරි ක්ලැරිෆයි කරගන්න පුළුවන්. සමහරට ඔය කට්ටිය අහන ප්‍රශ්න මටත් මේ හොයාගන්න බැරි වෙන්න ඉඩ තියෙනවා. හරි. එකපාරටම උත්තර දන්නේ නැති වෙන්න ඉඩ තියෙනවා. එතකොට ඉතින් අපිට මේ උදේස් සර්ගෙන්වත් අහලා තමයි ඔය ක්ලැරිෆයි කරගන්න වෙන්නේ. මේක මං හිතන්නේ මගේ එකේ නෙවෙයි වගේ රෙකෝඩ් වෙලා තියෙන්නේ නේද? හ්ම්.